Hey, it's been ages since I've done any videos whatsoever. I'm sorry about that. But in the meantime, I'm up a huge amount of subscribers. I think probably 30 in my absence. I'm up to 119 now. Thanks guys, that's awesome. So I have to pull my finger out and do a bit of a video. Haven't been super motivated lately, but I have been mucking around with this open sim wheel that I need to put on my simulator. Well, I want to put it on my simulator. I've used a treadmill motor, 1000 watt treadmill motor, steering wheel that's been through my Silvia and my Sigma and various other bits, but I'll go over it a bit closer. This is my Logitech G29 that I've probably shown in the other videos. I 3D printed a bit of a hub adapter so I could use a regular steering wheel for that. But the steering wheel itself, it really didn't like the bigger wheel and drifting. It just sounds like it's going to explode constantly, so hence doing the OSW. I had to change the load cell on the handbrake because that's been broken several times, and I added an E36 dash. Totally useless, but it's kind of cool having the tacho and the speedometer. This is the 3D printer I've been battling with for a while. Actually had to remake several parts of it. It's like a rep wrap armor rod and it's all printed out of PLA, and it was a good idea. It seemed cool at the time, but it's just so flimsy and weak. It's just basically useless. I spent more time trying to get it to work and print test cubes than making anything for this sim wheel, so I ended up coming across another printer that's far cheaper than this, obviously a lot newer, but works far better. So here's the rig as it stands. This is all PETG plastic, 3D printed. This is the original pulley set off the treadmill. So this is the original pulley that was on the treadmill. It had this big flywheel attached. I cut it off with the bandsaw and turned in the pulley on the lathe. Then this pulley had the belt roller originally up the middle of it, so I pushed the belt roller out and 3D printed this plastic piece, which has actually since broken from practicing drifting or testing drifting out on it, so I have to remake that. This is the replacement part. I put spots through for M6 bolts, go from the front to the back to hold it together, and then 3D printed it on this printer. This cost me $50 off Gumtree. Apparently it had a blown motherboard and it was missing the power supply and it was missing a bit off the extruder, but I got it home and all the guy had done is botched a firmware update, and I fixed the firmware, made the piece for the extruder, and off it went. I've been using it since. It's far better than another one. I mean, it's only a $300 printer new, but these are excellent. If you need a 3D printer, definitely check these out. The price performance is absolutely spot on. This is a Omron 200 count per revolution, I think. Encoder comes up as 8,000 ticks in the MMOS software. Yeah, it's just Chinese. I had to first one, the Z output didn't work. Had to get a new one from eBay, so it took quite a while for that to come through. For the control, I've used welding MOSFETs. Had them left over from when I repaired my welder at one point. They form an H-bridge. There's some high and low side MOSFET drivers for each side of the H-bridge. Ballast resistor to help me stop blowing so many MOSFETs, because I went through quite a few of them. That's an arcade isolation transformer, 240 to 120, gives me about 150 volts to drive the motor, which is actually a 180 volt motor, but it works just fine off that. A few caps to smooth it out, rectifier, normal gear. Then we have the MMOS board driving it. That's pretty standard affair. So I need to mount that all in the box and get it mounted on the sim and have some fun with it. Interestingly enough, that motor is so powerful, even with the ballast resistor at only 150 volts, that I can only get 30% out of it in the MMOS config without it tearing my arms off. Even at 30%, I have to drop the percentage down in Assetto Corsa because it wants to break my wrist. It's pretty aggressive. So this is the new hub. You see bolts I've got to go through to stop it from shearing off through the middle like the other one did. being PET G, it's oozed everywhere, so I have to drill all of the ooze away. I also need to tap the M5 threads for the steering wheel on the front, so the bolts fit through like so. So I don't think it's going to be possible for that to shear off with 6 bolts through like that. Well, having a horrible time trying to remove the old hub. Supposedly PET G is quite hard to glue, but I just glued that in here with some Loctite 460 and the core of it came away. The core with all its infill came out before the glue let go. Of course, the STM32 board does not have any mounting holes, so I'm going to have to 3D print a bracket about holding the box so it doesn't just float around in there and short out on the 150 volts and give me more of a hard time than I've already been having with this project. So we've just got a bracket that'll screw into the box, some notches for the PCB in the corners, and it should not take very long to print 2 of those. And now we have 2 monstrously stringy PET G STM32 mounts. So to bond the new hub to the pulley, it's already reasonably good fit. I've just roughed it up with some sandpaper so there's a bit of bite for the super glue. Loctite 460. I'll just give it a good dose in here. Can't be shy with the glue. I was going to use Gorilla Glue, but it actually didn't need it. This was not the failing point. And hopefully, in we go. And I'll drown it in some additional glue. And that should be sufficient to hold it in place. Then I can tap the shaft into place. It doesn't need to be very tight because it's only rotating the position sensor, so no glue required. Doesn't need to be very tight, but it is hella tight. Yeah, it's meant to have a circlip in that groove there, but those washers are now in the way, and it's so tight in there, I'm not even concerned. Right, before I go any further, I want to make a guard for this, because I'm terrified about me drifting and getting my finger go clean in there. Oh, this is throwing 1,000 watts. That would be not fun. There we have it, belt guard. That should keep my precious fingers from being degloved in the Mad Dory sessions. So I've created the biggest mess I've made in here for a while. This is what happens when I've got no idea where I'm actually going with this and only a vague plan in my head. Anyway, transformers mounted in the enclosure, heatsink, an H-bridge. I moved all the capacitors and added a whole lot more. 3D printed mounts for the STM32, the heatsink bracket, connector for the motor on the front, DC fuse, fan, some of the rear connectors for the sensor and for the pedals and gear stick, along with AC fusing switch and power inlet. So this went from going reasonably well, most of it fitted together and built up. Then I fired it up and I had no feedback. I stuck the meter down on this pin here, it snapped off It's a massive plasma arc. Took out the microcontroller board, 2 MOSFETs, and I don't know if the controllers are okay, but yeah, it's a bit of a disaster. I've got some more parts. I actually pulled some IGBTs out of an old inverter board that I had kicking around. They might be a little bit more robust, and they don't need the flyback diodes, so I'm going to give them a go. And I'm going to use some opto isolation from the digital pins from this, because the way it fried the earth wire on here was not very good. So I finally got it working. Played it for a couple of hours last night. Didn't have any major dramas. It got a little bit warm in here, then it cooled down. It was strange. The motor got very hot after several hours though, so that has to have a fan duct made for the back of it. Internally I changed to some different MOSFETs. These ones didn't seem to need the anti-parallel diodes. I also changed to some surface mount MOSFET controllers and added some high frequency, I've broken it. Added some high frequency op-amps, high frequency optocouplers to ensure this board does not explode so easily again. It seems to be going pretty well now, so happy with that. It's got a bit of drag one direction when it's supposed to be switched off, but it's not noticeable in game, so I'm pretty happy. I even CNC'd slots in the top cover at work, so that can go on. So yeah, just need to make that fan shroud, make the turbine fan go in the side to keep the motor cool, and she will be apples. And here we have just a minor sample of some of the silicon and fuses that got burnt. I think I went through nearly twice that in the end. Quite a poor effort, but at least it's working now. Right, so I finally got this going. I got in the house and I'm having a bit of play with the settings. I've got it on 100% force, max force. I don't know if I'm going to be able to show it down on there. This is 100% max force. Obviously with the belt, that's full noise. Now, that belt is just slipping. Right, so I've cranked the belt a bit tighter. Now I'm on 100% and it's like that is a lot of force. Certainly dangerous. That's pretty cool, but I'm thinking I'm going to pull this belt system up and just try it direct drive, because it is a bit ridiculous. You can hear the 50 hertz cut in, it's draining the caps. Because if the spring's turned up too high, you quit the game, the wheel's there, and it just goes bang, and you nearly lose your thumb. That happened to me almost a couple of times. So I'm just going to stick my LUT file for this wheel in some Ceticorsa and give that a go. Right, so I've got out the KTM. All force is on 100%. Gain 100. Gain in the MMOS tool is on 100. I had to turn down the minimum force to about 3% because it was just vibrating wildly. I don't know if that's meant to be engine noise or what, but anyway, this is going to be pretty hard to drive. So let's see if I can get it to move. Jesus Christ. Oh! Oh! Frick! Ah! Ah! It is so hard to hold onto the wheel. I don't even know what's going on. Ah! Oh, I can't. Whoa! 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 I should have put that emergency stop button. Fuck! Stop it. No, bad wheel. So as you can see, that is freaking psycho at 100%. Now, I could just turn down the force feedback. I reckon sane value would probably be about 20% of that. But this gear ratio is about 3 to 1, so why don't I just stick the wheel straight on the motor and see if I can have a direct drive set up. Right, so my print for the direct drive version of this hub is now complete. It's nearly identical to this one, except I've increased the centerboard to fit the motor and added a key and a bolt to hold it in place. Hopefully that keyway is not going to tear out of there, but we'll see. Hope it fits. No fiddling or anything. Like a glove. Well, it's a bit tight, but it's better to have it a little bit tight than loose with this, because it will flog out quite rapidly. Anyway, I'll tackle the threads, mount the wheel up, figure out a way to move the encoder to the back of the motor, put it back on the sim, and hopefully have some direct drive MMOS glory. Okay, so I've threaded and Loctited a bit of an extension into the back of the motor. Doesn't spin 100% true, but it's okay. Coupling takes that into account. I've picked up on one of the mounts for my fan shroud, which has somehow worked, despite being wrong about 4 or 5 times by now, but anyway, then I've folded up a piece of sheet metal, only one screw into here. It should still be right. It's probably a good idea to not mount these too rigidly anyway, so that they can move around rather than breaking the internals. And that's just going to bolt in there. That should work okay. I'll have to move my control box back, probably have to extend the wire on here to get that to work, and put the actual working encoder on there, not my broken dummy unit. Right, terrible lighting, but I tried the direct drive wheel setup, and when I did the force linearity test in wheel check, I was going backwards and forwards, and the motor shaft got so hot, it stripped the key out of that, and it was just sitting there doing nothing. So that was a fair bit of a fail. I just don't think DC motor does very well at such low RPMs with load on it like that. I'm not really sure what else is going on with it. I mean, the other problem too is the commutators. When in normal racing, it's only going to see about 2 or 3 pairs on the commutator all the time, and I think it's probably not a good idea to run direct drive with a DC motor. Didn't really see a lot of people having a major success with it on the internet. Maybe I haven't looked hard enough, but I've just gone back to the belt. I've cleaned the belt up quite a lot, removed all the belt grip I'd sprayed in there, and it's working pretty well now. I also had to make a stronger mount for the rear of it, because that did snap in continued testing, but since then I've put in many hours on this drifting, trying to drift. Had my birthday party and had a couple of people have a go on it with that as well, so it's been well and truly stress tested. Now there's been some funny findings with it, however. The min force in the feedback tool for the STM32, 12.44%. That's pretty high, because there's no dead zone, so that's okay. But the maximum force I had to run to get the linearity right is only 27%. And even at that, it still tries to tear the steering wheel clean out of your hands at full noise. So I've got the gain turned to 50%, I think, in Assetto Corsa, which is, yeah, it's still a huge amount of power. I mean, I guess the STM32 only has a 32-bit PWM mode, so I've only got about 10% of 65,000 for the amount of force each way, so say 6,500 possible force steps between min and max. I mean, it'd be nice to have it the full range. I'd have to make a closed loop current control system for that, because at the moment it's just open loop, and that's why I need to tweak this max force so much, but that could increase the resolution. But seriously, it's working fine. I reckon if I'm going to do something a bit more complicated, I'm going to use one of these direct drive washing machine motors and do a proper like 3-phase controller, it could be interesting, but I don't know, this is working really well. I mean, for drifting, do you really need that great of feedback, or do you just want it to spin back and go where the car's going really rapidly? Okay, so from iteratively changing this MMOS feedback tool, minimum force, maximum force, and going through the LUT file generator, I ended up with a very linear response. It was quite surprising. Okay, so there's my force linearity graph that comes out of this LUT generator. You can see it's basically flat the whole way. It only corrected 1 point in the file it generated, so I decided to not even use that. So it's pretty accurate. If that was terrible, which it was when I had max force up at 80%, or even more than about 30%, it would end up with a big flat spot at the top. But where it is there, it's got more than enough power, and it feels really good in game, so I'm just going to stick with it. I'm not going to make a closed loop current control. I just don't think it's worth it. I've spent so much time on this, just having it going is a lot better. So as I've done this video, I haven't really known what I've been doing, and there's been a lot of failure. It got a bit depressing there at some stage, especially building that H-bridge. I went through so many MOSFETs, it was ridiculous, and so many controllers, it was a bit depressing as well. But I did get through it, and if you want to know more about the build, just let me know. I might put it up in one of the forums like X Simulator or something and sort of cover it there, because I'm pretty impressed with the result now, and I've seen a few DC build and sort of other cheap wheel builds that people have done, and they haven't worked very well, so maybe there's something that people can glean out of this, and yeah, it'll be useful.